Welcome to the IM2 video lecture. This is covering the applications of the quadratic equation. Here I would like you to understand how to solve the quadratic equation when it comes to an area problem. The two success criteria that you should be able to do is 1. You should be able to determine what factor method to use when solving the quadratic equation, and 2. You should be able to find the length and the width of a rectangle. So we're going to review a core concept. These are your 4 methods of solving a quadratic equation. Method 1 is going to be the graphing method. This always works, but the problem is it's not always exact. Sometimes you get a decimal answer, but this is going to be the easiest method to use. Second is going to be the factoring method, and the one that I show you is going to be the diamond method of factoring. This sometimes works, and the criteria of it is when a equals to 1. Okay. Also, please understand that if the constant term is 0 or factors are easily determined. Also understand that this is going to be medium level difficulty. Next, you complete the square, and it always works. Completing the square allows you to turn something unfactorable into factorable. Okay, and it's useful when that b term is an even number because you have to divide it by 2. Okay, and our last method is going to be the quadratic equation. This one always works, but this method, some students find it harder, but it always works. Okay, you could either get rational or irrational solutions. So these are the 4 methods, but in reality you only need 3, which is graphing, factoring, and then the quadratic formula. So you have a problem like this. The area of this is defined by this quadratic equation of negative x squared plus 2x plus 3. That equals to a length times the width. The length and the width are basically their factors. So we have to determine what method to use to solve for the quadratic equation. Notice here a is equal to negative 1. So we can say we cannot use the diamond method of factoring. Okay, so we can either use the quadratic equation or graphing. So in this case, I'm going to graph it. I plug that in, y equals to negative x squared plus 2x plus 3, and I look for the x-intercepts. The solutions are your x-intercepts. So x equals to 1 and x equals to negative 3. This is where x is equal to negative 1, and this is when x equals to 3. So, but I want the factors, so I have to work backwards to get the factors. I have to add 1 to both sides. That get me x plus 1 equals to 0. On the other one, I minus 3 to both sides. I get x minus 3 equals to 0. The factors are x plus 1 times x minus 3. So that is my length, which is x plus 1. And my width is the other factor of x minus 3. Notice the factoring of this quadratic equation give me the length and the width. Because if we FOIL this together, you will get that. So this is how we found the length and the width using the graphing method. Next, we have this. Same problem, but the numbers are different. This is x squared plus 9x plus 20. That's going to be equal to your length times your width. A equals to 1. Perfect. Therefore, we can use the diamond method of factoring. A was equal to 1, B was equal to 9, C equals was 20. We're going to find two numbers that multiply to 20 that adds to 9. The two numbers that multiply to 20 are 5 and 4. If you add those, that also equals to 9. Your two factors here are 5 and 4. So in factored form, that gets you x plus 5 times x plus 4. That is your length, which is x plus 5. And your width is your x plus 4. There you go. Next, this is when you have this equation. But here a is equal to 2. We cannot use the we cannot use the factoring method because a is not equal to 1. Let's try graphing it. So if we graph it, x y equals to x squared, 2x squared minus 5x plus 3. Okay, I mean, it looks okay, somewhat neat. We have a 1 and 1.5. Do you see? When you graph, sometimes you get a decimal. Not good. So let's do the other method, right? So we're just going to use the quadratic equation here. So a equals to 2, b equals to -5, c equals to 3. This is a similar problem, so I'm going to go over the details a little bit quicker. Okay, plug it in. X is equal to negative times -5 plus and minus radical -5 squared minus 4 times 2 times 3 divided by 2 times 2. Simplify, you get x equals to 5 plus and minus radical 1 divided by 4. Radical 1 can be broken down to just 1. Your two solutions are x equals to 5 plus 1 divided by 4, which simplifies to 3 over 2. The second solution is x equals to 5 minus 1 divided by 4. That gets you 1. Notice, this 3 over 2 is the same thing as 1.5, okay? We should already saw that in our graph. Now, we want to work backwards to get the factors. So, for x equals to 3 over 2, you want to multiply by 2 to both sides. So this should cancel out. You get 2x on the left and a 3 on the right. Divide by 3, subtract 3 to both sides now. You get 2x minus 3 equals to 0. Other side, you just subtract 1. You get x minus 1 equals to 0. So my length here is 2x minus 3, and my width here is x minus 1. There you go. That is everything that you need to understand. I show you one example of this where you use the quadratic equation. I showed you one where you use the factoring method, and I showed you one where you use the graphing method. The graphing method and the quadratic equation gave you the solution automatically, so you actually had to work backwards to get the factors. Likewise, vice versa, the diamond method is the easiest when it comes to finding the factors because it automatically pumps out the factor form once you factor it using the diamond method. All right, but there you go. That is everything that you need to understand when it comes to the application of the quadratic equation.